This will be the straight coupling project for the coupling assembly. So make sure you download your project pages. And I put a bookmark in here for each one of the projects. And we're going to go to the straight coupling. We did the taper coupling last time. And I'll close this off. So straight coupling is much easier than the one with the taper. It has fewer features. And we'll simply go through the model player. Start from the very beginning. And you'll see the first feature. And the first feature takes all the outside dimensions. Did not put the cut down the middle. And this is okay. You can actually add the fillet here. You could have added the fillet here because it's really not a fillet. It's more of a giant arc for the outside features. A round and fillet round is usually considered a smaller item. But you don't have to. You can add it later. Or like here, which is the second feature. Add it round. Oh, not too far. So then we have the hole down the middle. And see the dimensions for the hole. Got a chamfer put in. Probably could have added that with the hole. And we have the key seat. And we have the patterned hole. And in this case, it looks like it's, again, a revolved cut. Done with a slot command, which is a revolved cut, basically. Added a round at the very end, a small round. And another chamfer down here in the bottom. And a little round on the inside. Round cut, looks like. We'll look at it later. Then the small hole. Which has been patterned. Looks like it's missing its diameter dimension. We'll have to take a look at that. All right, let's close it. So let's look at each one of the features. Let's roll it back to the beginning. Our first feature, fairly simple. Going to do revolution, revolved. And you'll see that we do get the little counter bore cut on the bottom in this, and that's okay. Again, you can add your round here, your fillet, rather than waiting till later and putting it as a pick and place feature. Next one, we added the round. And next one, the hole. And again, this is just a simple hole feature. It's nothing fancy. You can see it's placed axially and from the top, and with the diameter, and it's cut all the way through. And you got your chamfer on top here, and you got your cut. Now let's take a look at this cut here. Edit the definition of it, and let's go back and get it into the sketch view. And again, you'll see that this person did it from the end here. And I think that's not really the best way to do it, so we'll cover that one more time. So let's use DTM3 as the sketching plane. Now let's give the command first, and then we'll select the remove material. Then we'll pick on the sketch plane. And we'll have to go over and do the hidden line. And again, what you can do is you can add your references for the top. If you want, you can add the reference for the edge of the hole here, and you've got one for the very bottom. So this is nothing more than a line from the very top to the very bottom. Go all the way to the bottom. Don't go to this counterbore cut, even though that is in the first protrusion. And you can change the size. I'll leave it fairly large here. We'll go back over to our standard orientation and our shading. And you can see what it's going to cut here. And we want it to be symmetrical. Like so. So again, with one line, you're doing the same amount of work as over here, a lot less work, I should say, accomplishing the same thing. I would think this is always the better way to do it. All right, so we'll take that out. Next is the slot here. And again, this is an old style command. So it'll come up with an odd looking dialog, but when you do it, it'll be a revolved cut. You'll simply go up in here and select that. Or you can put it in as a whole. But I like this one to show you because it's got an interesting way of doing it. So we'll go into the section, sketch view, and one thing they didn't do correctly is they did not put in a diameter dimension. So that's one thing let's correct. So center line, line, center line. Oh, didn't get it. So let's see what they've got here. That's a line, not a center line. So let's put in a center line first. Construction center line. All right. And then the dimension. So center line, line, center line. And get rid of the small one there. Now, one thing I do want to do is I want to make sure that this center line over here is the designated axis of revolution. If you remember when I was doing the taper, I didn't do this, and so what it did is it swung the cut from the center and it cut everything out in the shape. So we do want to make sure that the axis of revolution is the axis here. And I'm going to check that first and see if I got it okay. It's okay. So let's go back in again to the section. Let's do something else to provide us with a little bit more control over it. Two center lines went in. This one is the axis of revolution. We've got the diameter now. If you put this in as an axis of revolution in the very beginning, then these diameter dimensions will go in automatically. But this is really more of a spot face. And if you want to control it to always go to the top of this tangency, we can add a reference. So you put your cursor here, it says round, but if you hit your right mouse button quickly, it'll pick the, or highlight, pre-select the edge, and that's what you want for a new reference. And then we'll go and we'll put it on coincident, and we'll click on the top of the counterbore and the reference, and we'll get rid of the dimension. So now you'll see it's controlled no matter how big the radius gets in here, this will always pass through it. It's just a better way of controlling it. Again, you can put it in with a hole if you wish. And next thing is just a simple round on the top. Next is a chamfer on the bottom. Nothing important about those. Then we have a round. And we have another round on the outside here. Then we have a hole. And let's take a look at this hole. Alright, so one thing is missing. We should have done a diameter in here. So if we go into placement, you'll see it's radial. This really should have been diameter. It gives us a bolt circle that way. Okay, and let's turn on everything in the model tree in case there's some notes we want to see. And we have our group here. Now that's interesting. Why is it way out there? I think they did this wrong. I'm going to delete it. And the hole, if we go to pattern and axial pattern, it's only going to be 2 and 180. And that's how you put it in there. That way you do get the other items. Now, this has got a couple of other datum planes in here, and the reason for that probably is that the person who modeled it put in some sections. And let's see, yes, there's some sections. So let's set this one as active. Nice to see the internal here. Goes through the spot face. You can use this when you do a drawing. That's why they did it. And we'll set this one as active. So those were 2 datum planes that were added so that they could do the sectioning. I'm not sure why they did it like that. It seems like this would have been a good datum plane for section A. The other one didn't go through the hole, so I see why they added that. This concludes the straight coupling.